Hi friends, my name is Maruti and I'm the co-founder of Kraku. In this video, we'll be looking at 30 plus number systems questions for CAT. Most of these questions are taken from the previous year's papers for CAT, which I think are a very good resource for students to practice CAT level questions. So the question will be first displayed. After that, there will be a video solution explaining the question. I would recommend you to pause the video and try to solve the question on your own. If you're not able to get it or if you want to see how I have solved it, then you can look at the video solution. If you found this video to be useful, I would recommend you to check out two playlists that we have. One playlist is the CAT revision playlist, where we are having two videos where the entire concepts, all the important formulae for CAT are explained. There is one video where you can revise the entire portion for verbal within 1.5 hours. And there is one video where you get the basics of all the important types of LRDs that are asked. This is the CAT revision playlist and it is watched by lakhs of people. The second most important playlist is the set of topic-wise questions that we have made, similar to the one that we have made in this particular video. You will find topic-wise questions in arithmetic, algebra, geometry, modern maths and number systems. Again, lakhs of students have watched this question videos, so definitely check out the playlist of the topic-wise questions as well. The links for both of them are given in the description of this video. If you find this video to be useful, please do like it, and if you are having trouble with any of the questions that I have solved in the video, please do comment below this video. I look at all the comments and I'll try to respond to them to the best of my ability. In this question, we are told that n is the least positive integer such that 168 is a factor of 1134 to the power n. What is 168? If you are doing the prime factorization of 168, this is 2 into 84 or this is 8 into 21. So this is 2 cube into 3 into 7. That is the prime factorization of 168. What is the prime factorization of 1134? 1134 is equal to 2 into 567. What is 567? It is 7 into 81. So this is 2 into 3 to the power 4, which is 81 into 7. What we are told is that 168 is a factor of 1134 to the power n, or 2 cube into 3 into 7 is a factor of 2 to the power n into 3 to the power 4n into 7 to the power n. This is basically 1134 to the power n. When will this happen? This will happen only if n is greater than or equal to 3. This is the power of 2. 4n is greater than or equal to 1. And n is greater than or equal to 1. All three of them have to match. All three of them have to be satisfied. That is, the power of 2 in the factor has to be less than or equal to the power of the factor in the multiple. That is, 2 cube has to be less than or equal to 2 to the power n. 3 to the power 1 has to be less than or equal to 3 to the power 4n. 7 to the power 1 has to be less than or equal to 7 to the power n. All three of them have to be satisfied, and they will be satisfied essentially if n is greater than or equal to 3. And because n is the smallest integer for which this is satisfied, the value of n is equal to 3. Once we are told this, we are also told that m is the least positive integer such that 1134 to the power n is a factor of 168 to the power m. What is 1134 to the power n? 1134 to the power n is equal to 1134 whole cube. 1134 is 2 into 3 to the power 4 into 7. So this is equal to 2 cube into 3 to the power 12 into 7 cube. This, we are told, is a factor of 168 to the power m. 168 to the power m is 2 cube into 3 into 7 whole to the power m. This is 168 to the power m. This is 2 to the power 3m into 3 to the power m into 7 to the power m. Again, if this number is a factor of this number, it would imply that 2 cube has to be less than or equal to 2 to the power 3m. That is, 3 has to be less than or equal to 3m. 3 to the power 12 has to be less than or equal to 3 to the power m. So 12 has to be less than or equal to m. And 7 cube has to be less than or equal to 7 to the power m, or 3 has to be less than or equal to m. All three of these inequalities have to be satisfied. And the smallest value of m for which this is satisfied is if m is equal to 12. So m is equal to 12, n is equal to 3. The value of m plus n will be equal to 15, which is option B. In this question, we are asked to calculate the number of natural numbers up to 1000 with non-repeating digits. If you are looking at single digit natural numbers. All of them will have unique digits because there is only one digit in them, and those numbers are from 1 to 9, and so we'll have 9 of them. Suppose we are looking at double digit natural numbers, that is the numbers from 10 to 99. It will have 2 digits. The first digit can be any number from 1 to 9. It cannot be 0. So this can be represented in 9 ways. The second digit can be any of the numbers including 0, which is not the first number. So this can be another 9. So the total is 81. If you are looking at 3-digit natural numbers, you will have 3 digits. The first digit can be again any number which is not equal to 0 from 1 to 9. So it can be selected in 9 ways. The second digit can be 0, but we have to ignore the first digit. So it can be selected in 9 ways. The third digit cannot be the first digit and the second digit. So it can be any one of the remaining 8 digits. This is 9 into 9 into 8, which is 648. So the total number of natural numbers which are less than 1000 with non-unique digits is 648 plus 81 plus 9, which is equal to 738. So the answer for this question is option C. In this question, we are required to calculate the sum of the first 2 natural numbers, each of which has 15 factors, including 1 and the number itself. Before we actually answer this question, let us try to understand what is the number of factors of a particular number. If you have a number n, and if you are doing the prime factorization of n, that is if you are writing n as p1 to the power a1 into p2 to the power a2 into p3 to the power a3 and so on into pr to the power ar, where p1, p2, p3 dot 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 till pr are prime numbers, then the number of factors of n is a1 plus 1 into a2 plus 1 into dot 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 into ar plus 1. This is the number of factors. What we are told is that this number has 15 factors. So this product is equal to 15. How can you express 15 as a product of some numbers? Either that is 1 into 15, or the other way around, it is 15 into 1, or it is 3 into 5, or 5 into 3. In the first case, if it is 1 into 15, basically what we are saying is that this is of the form a prime number p to the power 14. Even over here, it will be a prime number p to the power 14. In this case, it has 2 prime factors, and this will be of the form p1 square into p2 to the power 4. This also it will be similar, it will be p1 to the power 4 into p2 square. The smallest number which is of the form p to the power 14 is 2 to the power 14. The smallest number which is of the form p1 square into p2 to the power 4 is 2 square into 3 to the power 4. We can also have it another way around. We can have it as 3 square into 2 to the power 4. These are basically the numbers that we have to consider. 2 square into 3 to the power 4 will be 4 into 3 to the power 4 is 81. This is equal to 324. 3 square into 2 to the power 4 is 9 into 16, which is 144. 2 to the power 14 is very large. We know that 2 to the power 10 is 1024. So 1024 into 2 to the power 4 is 16. This is greater than 16,000. This is very large, so we can ignore it. So the 2 smallest numbers which have 15 factors are 324 and 144. And their sum is equal to 468. So the answer for this question is 468. In this question, we are told that the number of coins that are collected per week by 2 collectors A and B are in the ratio 3:4. So we have in 1 week, the number of coins that are collected by A and B are in the ratio 3:4. So A would be say 3x, B would be 4x. The total number of coins collected by A in 5 weeks is a multiple of 7. So what is the total number of coins collected by A in 5 weeks? That will be 15x. So what we are told is that 15x is a multiple of 7. For this to happen, the only possibility is that x itself has to be a multiple of 7, because there is no common factor between 15 and 7. So if x is any number, say 1, 2, 3, 4 or 5 or 6, it won't be 15 into that number will not be a multiple of 7. For 15x to be a multiple of 7, x has to be either 7 or 14 or 21 or 28 or some number which is a multiple of 7. So let us assume that x is of the form say 7y. Therefore, the number of coins collected by A in 1 week will be 3x, which is 21y. The number of coins collected by B in 1 week will be 4x, which is 28y. Therefore, the number of coins collected by A in 5 weeks will be 21y into 5, which is equal to 105y. 105 is a multiple of 7, so this adds up. So in 1 week, the A is collecting 21y coins, B is collecting 28y coins. Now what we are told is that the number of coins collected by B in 3 weeks is a multiple of 24. What is the number of coins collected by B in 3 weeks? That will be 28y into 3, which is equal to 84y. Now can we say, like we said earlier, if 84y is a multiple of 24, can we say directly that y has to be a multiple of 24? We can't say that. Why can't we say that? Because now 84 and 24 have some common factors. So for example, 84y, we'll write it as 12 into 7y. So 12 into 7y is a multiple of 24, which is 12 into 2. This 12 and this 12 are common. But if you now eliminate it, we want 7y to be a multiple of 2. Now for 7y to be a multiple of 2, y has to be a multiple of 2. Because 7y is even. 7y is a multiple of 2. And there is no common factor between 7 and 2. So now we can imply that y has to be a multiple of 2. As long as you have common factors, remove those common factors. Now you are finding 7y and 2. So we are saying that y has to be a multiple of 2. So let y be equal to 2z. If y is equal to 2z, in 1 week, the number of coins collected by A, which is 21y, will be 42z. And the number of coins collected by B in 1 week will be 28y, which is 56z. So what is the minimum number of coins collected by A in 1 week? That will happen when z is equal to 1. And the minimum number of coins collected by A in 1 week will be 42. In this question, we are told that A, B, M and N are natural numbers such that A is greater than 1, B is greater than 1, and A to the power M into B to the power N is 144 to the power 145. We are asked to calculate the largest possible value of N minus M. What is 144? 144 is 16 into 9, which is 2 to the power 4 into 3 square. This is the value of 144. So 144 to the power 145 is equal to 2 to the power 580 into 3 to the power 290. So A to the power M into B to the power N is equal to 2 to the power 580 into 3 to the power 290. We are asked to maximize the value of N minus M. So we want the maximum value of N and we want the minimum value of M. What is the maximum value of N? The maximum value of N is 580. This will happen when B is 2. And what is the minimum value of M? The minimum value of M will be equal to 1, and this will happen when A is equal to 3 to the power 290. Therefore, the maximum value of N minus M will be 580 minus 1, which is equal to 579. In this particular case, what we are saying is A to the power M into B to the power N will be 3 to the power 290, which is the value of A, whole to the power 1 into 2 to the power 580. This is the value of A, this is the value of B, this will be the value of N, this will be the value of M. So the maximum value of N minus M will be 579, which is option D. In this question, we are told that for any natural number M, N and K, K divides both M plus 2N and 3M plus 4N. Then K must be a common divisor of. Let us assume that M plus 2N is equal to some natural number P into K. And let 3M plus 4N be equal to another natural number Q into K. Now if you multiply this one with 2, we are going to get 2M plus 4N is equal to 2PK. Or the value of M is equal to Q minus 2P into K. Q minus 2P will be some other natural number. This would imply that K has to be a divisor of M. Let us try to calculate the value of N. If you are looking at the value of N, let us multiply this one with 3. So we are going to get 3M
plus 6n is equal to 3pk, and this one is 3m plus 4n is equal to qk. If you subtract one from the other, we are going to get 2n is equal to 3p minus q into k. So again we can say that k is also a divisor of 2n. We can't say that k is a divisor of n, but we know that k will divide 2n. So we can say for sure that k has to be a common divisor of both m and 2n, which is option C. In this question, we are asked to calculate the number of positive integers which are less than 50, having exactly two distinct factors other than 1 and itself. So if you are assuming that this number is n, we are looking for all the values of n which are less than 50, which are of the form that it has a total of 4 factors. One of them is 1, one of them is n, and we have a and b over here, which are in the middle. The first thing it will tell you is that a into b has to be equal to n. Now, are a and b prime numbers? One thing we can say is that a has to be a prime number. This number over here has to be a prime number, because if it is a composite number, there should be some factor which lies between 1 and a. So the smallest factor other than 1 of any number will be a prime number. So a over here is definitely a prime number. What about b? Now b has to be either a square or b has to be another prime number. Let us look at both the cases. First, we are looking at the case where b is a square. So basically the number n is of the form 1, a prime number p, the square of a prime number p square, and this number will be p cube. So you will have two such numbers which are less than 50. What are those two numbers? They are 1, 2, 2 square and 2 cube. This is 8. Or 1, 3, 3 square and 3 cube, which is 27. The next number will be 1, 5, 5 square and 5 cube, which is 125, which is greater than 50. So this is not allowed. These two are allowed. In the second case, we are assuming that b is a prime number. So basically we have 1, we have a prime number p, p1 say, and we have another prime number p2, and we have n. And the value of n is one prime number p1 into another prime number p2. What are all the cases that are possible? Over here there is no easy way to do it. We have to just manually enumerate it. We'll first assume that p1 is equal to 2, then p2 will be either 3 or 5 or 7 or 11 or 13 or 17 or 19 or 23. In this case, the value of n in the first case will be 6, 10, 14, 22, 26, 34, 38 and 46. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 cases over here. What will happen when p1 is 3? So we have 1, we have p1 which is 3, and we are looking for another prime number p2. p2 will be either 5 or 7 or 11 or 13. Once it becomes 17, 3 into 17 will be 51, which is greater than 50. So here we are going to get 15, 21, 33 and 39. So here we have 4 cases. What will happen when p1 is 5? So we have 1, 5, and the second prime number p2 has to be 7. The next prime number is 11. 5 into 11 is 55, which is greater than 50. So this will be 35. So the value that n will take is 35. If the first prime number is 7 and the second prime number is 11, the product itself is 77. So this can be cancelled. So the total number of values is 2 over here. This is if n is of the form p cube. So we have the 4 factors as 1, p, p square and p cube. We have 2 such cases. Or we'll have 8 cases where the first prime number is 2 and the second prime number will be any one of them. This is 8 cases. We have 4 cases where the first prime number is 3 and the second prime number is either 5 or 7 or 11 or 13. And the last case is the first prime number is 5 and the second prime number is 7. So the total is 2 plus 8 plus 4 plus 1, which is equal to 15. This involves a lot of enumeration, but that is the only way to solve this question. In this question, we are told that a is the largest positive integer that divides all the numbers of the form 3 to the power k plus 4 to the power k plus 5 to the power k, and b is the largest integer that divides all the numbers of the form 4 to the power k plus 3 into 4 to the power k plus 4 to the power k plus 2. If you are looking at b is the number which divides every number which is of the form 4 to the power k plus 3 into 4 to the power k plus 4 to the power k plus 2. 4 to the power k plus 2 is basically of the form 4 to the power k into 16, because that is 4 to the power k into 4 square, plus 3 into 4 to the power k plus 4 to the power k. So now if you are taking 4 to the power k common, this is 1 plus 3 plus 16. This is equal to 4 to the power k into 20. So b is the number which divides every number which is of the form 20 into 4 to the power k. So the value of b will be when k is equal to 1, this is equal to 80. Because if you are looking at b, that is the HCF of all the numbers which are of the form 20 into 4 to the power k. So that is 20 into 4, 20 into 4 square, 20 into 4 cube, and so on. So clearly the HCF is 20 into 4, which is 80, which will be the value of b. If you are looking at a is the HCF of, or the highest common factor of, all the numbers which are of the form 3 to the power k plus 4 to the power k plus 5 to the power k. In case of a, we can't really factorize or simplify this given expression. In case of b, this sum could be easily factorized, and we can simplify it to the form 20 into 4 to the power k. So what we will do for a is, we will substitute the value of k to be equal to 1, calculate the value of a, then we will put k to be equal to 2, calculate the value of that sum, then we will see if we can find out a HCF. If you are substituting the value of k to be equal to 1, this will be equal to this sum 3 to the power k plus 4 to the power k plus 5 to the power k is equal to 12. If k is equal to 2, that will be equal to 9 plus 16 plus 25, which is equal to 50. If k is equal to 3, this is 27 plus 64 plus 125. Now you would figure out that if you are looking at these two, for example, the HCF of these two numbers is equal to 2. And every number which is of the form 3 to the power k plus 4 to the power k plus 5 to the power k will be an even number. Because 3 to the power k will be odd, 5 to the power k will be odd. So the sum of two odd numbers will be even. Add that to 4 to the power k, which will be even. So you are going to get an even number. So the HCF of all the numbers in this particular series will be equal to 2. Or the value of a is equal to 2. So a plus b will be equal to 82. That will be the answer. In this question, we are told that there is a natural number n such that 15,000 factorial is divisible by n factorial factorial. 15,000 factorial is divisible by n factorial factorial. We are required to calculate the largest possible value of n. Now, if you are told that 15,000 factorial is divisible by a number a factorial, that is, we are just replacing n factorial with a. If 15,000 factorial is divisible by a factorial, it would imply necessarily that 15,000 is greater than or equal to a. In this particular case, because we are looking at n factorial factorial, we want n factorial to be strictly less than or equal to 15,000. What is the largest possible value of n for which this is true? When n is equal to 6, n factorial is equal to 720. When n is equal to 7, n factorial will be equal to 720 into 7, which is equal to 5040. When n is equal to 8, n factorial is equal to 5040 into 8, which is 40,320. This is greater than 15,000. So the maximum possible value of n is 7, which is option B.
Google search Krakow CAT formulas PDF, click on the first link. You will get a list of topics for CAT. Click on one of the topics, download the PDF to get a list of formulas for the topic.
In this question, we are told that there are 6 distinct natural numbers such that the average of the two smallest numbers is 14 and the average of the two largest number is 28. We are required to calculate the maximum possible average of these 6 numbers. Let the 6 numbers be A, B, C, D, E and F in that order such that A is less than, B is less than, C is less than, D is less than, E is less than F. The average of the two smallest numbers is 14. Therefore, their sum is 14 into 2, which is equal to 28. The average of the two largest numbers E and F is 28. So their sum will be 28 into 2, which is equal to 56. In order to maximize the average, we have to maximize the sum of C plus D. What is the maximum possible value of D? That will be dependent on the maximum possible value of E, because we know for sure that D is less than E. And if you know that E plus F is equal to 56, that is the average of E and F is 28, the maximum possible value of E will be 27. Because if E is 28, F will be greater than 28 and their average will be greater than 28. So the maximum possible value of E is 27, in which case the value of F will be equal to 29. And the maximum possible value of D is equal to 26, which is just 1 less than 27. And the maximum possible value of C is 25, which is just 1 less than 26. So the maximum possible sum of C and D will be 26 plus 25, which is 51. Therefore, the maximum possible sum of the 6 numbers is 28 plus 51 plus 56, which is equal to 135, and their average is 135 divided by 6, which is equal to 45 divided by 2, which is equal to 22.5. So the value is option D. That will be the correct answer. In this question, we are told that there is a school which has less than 5,000 students, and if the number of students are divided equally into either 9 or 10 or 12 or 25 teams, then there are exactly 4 which are always left. So what this means is, if you assume that the number of students is equal to S, and if you deduct 4 from S, that is S minus 4, S minus 4 is a multiple of 9, it is a multiple of 10, it is a multiple of 12, it is a multiple of 25. So S minus 4 is a multiple of the LCM of 9, 10, 12 and 25. What is the least common multiple? That is the smallest number, which is a multiple of 9, 10, 12 and 25. The smallest multiple of 9 and 12 is 36. The smallest multiple of 10 and 25 is 100. So we have to find out the smallest multiple of 36 and 100. You can figure out that the smallest multiple of 36 and 100 is equal to 900. You can do that because you can essentially divide 36 into 4 into 9. And you know that 4 is a factor of 100, so it won't matter. So that number, which is a least common multiple, has to be a multiple of 9 and 100, which is 900. So S minus 4 is a multiple of 900 and S is less than 5000. So the possible values for S are either 904 or 1804 or 2704 or 3604 or 4504. Now we are told that if the students are divided into teams of 11 each, no one is left. That is, one of these has to definitely be a multiple of 11. That will be the value of S. Which of them is a multiple of 11? To calculate if a number is a multiple of 11, the easiest thing to do is to figure out the sum of the digits in the even numbers and sum of the digits in the odd places. If the difference between both of these sums is a multiple of 11, the entire number will be a multiple of 11. Here, for example, 904 is not a multiple of 11 because the sum of the digits in the odd places is 9 plus 4, which is 13, which is not a multiple of 11. Here the sum of the digits in the odd places is 1 and the sum of the digits in the even places is 8 plus 4, which is 12. 12 minus 1 is equal to 11, which is a multiple of 11. So this is a multiple of 11. If you're looking at the next one, 2 plus 0 is 2, 7 plus 4 is 11, 11 minus 2 is 9, so this is not a multiple of 11. Similarly, this is 3 plus 0, which is 3, and 6 plus 4, which is 10, so the difference is 7, which is not a multiple of 11. In the last case, 4 plus 0 is 4, 5 plus 4 is 9, the difference is 5, so this is not a multiple of 11. The only number which is a multiple of 11 is 1804, which will be the number of students in the school. Now, if they are divided into teams of 12 each, the maximum number of teams that can be formed is the value of 1804 divided by 12, the integer value of it, which is equal to 150. So the answer for this question is 150. In this question, we are told that n is a integer and the value of 2 plus 2 to the power n plus 2 lies between 2.25 and 202. We are asked to calculate the number of integer values that 3 plus 3 to the power n plus 1 can take. If you are looking at the inequality that is given to us, 2.25 is less than or equal to 2 plus 2 to the power n plus 2, which is less than or equal to 202. If you are subtracting 2 from all the inequalities, we are going to get that 0.25 is less than or equal to 2 to the power n plus 2, which is less than or equal to 200. 0.25 is 1 by 4, that is 2 to the power minus 2. And 200 lies between 128 and 256, which are both powers of 2. That is, this is 2 to the power 7 and this is 2 to the power 8. So if you are looking at it, this is 2 to the power minus 2 is less than or equal to 2 to the power n plus 2, which is now less than 256, which is 2 to the power 8. Or the value of n plus 2 is greater than or equal to minus 2 and this is less than 8. Or the value of n is greater than or equal to minus 4 and this is less than 6. So the values that n can take are minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4 and 5. These are all the values that n can take. We are asked to find out the number of integer values that 3 plus 3 to the power n plus 1 can take. 3 is an integer, so for this we can ignore it. We want 3 to the power n plus 1 to be an integer. So n plus 1 should be greater than or equal to 0. Because if n plus 1 is less than or equal to 0, 3 to the power that number will be a fraction. For example, 3 to the power minus 1 is 1 by 3, which is a fraction. If you are adding 3 to it, which is an integer, you will still have only a fraction, which is in this particular case 10 by 3. So we want n plus 1 to be greater than or equal to 0, or we want n to be greater than or equal to minus 1. So the values that n can take will be minus 1, 0, 1, 2, 3, 4 and 5. So n can take 7 values, and for each of the values we will be getting an integer value for 3 plus 3 to the power n plus 1. So the correct answer for this question is 7. In this question we are told that there is a 4-digit number like this, and the sum of the digits in the thousands place, hundreds place and tens place, these 3 numbers add up to 14. And we are also told that the sum of the hundreds place, tens place and units place, these 3 sum up to 15. You should notice that the number in the hundreds and the tens place is common in both of these equations. And the first sum is 14, where you are having the thousands place number, and the second sum is 15 when you are adding the units place number. This would imply that if you are having a as the number in the thousands place, the number in the units place will be a plus 1. We are also told that the tens place digit is 4 more than the units place digit. So this becomes equal to a plus 5. The sum of these 3 is equal to 14. So the number in the hundreds place will be 14 minus a, which is the thousands place digit, minus a plus 5. Or if you simplify this, this will be equal to 9 minus 2a. As we assumed that the number in the units place is a plus 1, these 3 when you sum up will automatically be equal to 15. Now what we are asked to find out is the highest possible 4-digit number satisfying these conditions. Now the number is of the form a, 9 minus 2a, a plus 5 and a plus 1. These are the 4 digits. So as you increase the value of a, the thousands place number increases, and so the value of the number also increases. But what is the maximum value of a? We want 9 minus 2a to also be a positive number, or at least a non-negative number. You don't want to have minus 1 or minus 2 as one of the digits. So this would imply that 9 minus 2a has to be greater than or equal to 0, or 2a has to be less than or equal to 9, or the value of a is less than or equal to 4.5. As a has to be an integer, the maximum value of a is 4. So the thousands place will be 4, the hundreds place will be 9 minus 2 times 4, which is 1. The tens place will be a plus 5, that is 4 plus 5, which is 9. And the units place will be a plus 1, that is 4 plus 1, which is equal to 5. So the maximum possible such number is 4195. In this question we are asked to find out how many 3-digit numbers are there such that the product of their digits is more than 2 and less than 7. Let us assume that a 3-digit number a, b, c satisfies this condition. So the product of its digits, that is a into b into c, is greater than 2 and a into b into c is less than 7. So the possibilities are that a into b into c is equal to 3, or a into b into c is equal to 4, or a into b into c is equal to 5, or a into b into c is equal to 6. These are the 4 possibilities. For each one of them, let us calculate the of numbers that are possible for this. If the product of three numbers is equal to 3, the only case in which this will happen is if the three digits are 1, 1 and 3 in some order. And how many such numbers are possible? We have to fix 3 in either the first place or the second place or the third place. So the total number of ways in which this is possible is 3. Similarly, if you have the product of three numbers to be equal to 4, here you have two cases. One case is that they are 1, 1 and 4 in some order, or they are 1, 2 and 2 in some order. 1, 1 and 4 can be done in three ways. Basically, you have to figure out whether 4 is in the first place or the second place or the third place. So there are three cases possible. And 1, 2, 2 can also be decided in three ways. Here we have to figure out whether 1 is in the first place or the second place or the third place. So again, you have three cases. So the overall total is 6 cases. In the third scenario, when the product of the numbers a, b and c is equal to 5, the only way in which this is possible is if the three numbers are 1, 1 and 5 in some order. And the number of numbers for which this is true is again equal to 3, basically depending on which position the number 5 actually is in. In the final case where the product is equal to 6, we have two cases. Either the three numbers are 1, 1, 6 in some order, or they are 1, 2 and 3 in some order. 1, 1 and 6, the number of three digit numbers which can be formed using 1, 1 and 6 is equal to 3, depending on where 6 is. And if you are using the three digits 1, 2 and 3, the number of three digit numbers that you can form is equal to 3 factorial, which is equal to 6. Because you can decide which position in three ways, and once you fix the position of 3, you can fix the position of 2 in two other ways, and the remaining position will go to 1. So the total is 3 into 2 into 1, which is equal to 6, or the total number of cases in this particular scenario is equal to 9. So the overall total is 3 plus 6, which is equal to 9, plus 3, which is equal to 12, plus 9, which is equal to 21. So you will find 21 three digit numbers such that the product of their digits is greater than 2 and less than 7. In this question, we are asked to find out the mean of all the 4 digit even natural numbers which are of the form AA, BB, where A is greater than 0. So the first two digits are the same and the last two digits are the same, and we are told that all of them have to be even. So if you look only at the last two digits, what are the possible values for the last two digits? That is, what is the value of BB? It can be either 0, 0, or it can be 2, 2, or it can be 4, 4, or 6, 6, or 8, 8. How many 0, 0s will be there? That will be dependent on what the AS are. But what you can say for sure is that in the entire list, the number of 0, 0s will be exactly the same as the number of 2, 2s, which will again be exactly same as the number of 4, 4s, number of 6, 6, and number of 8, 8s. So if you are looking only for the average, by symmetry, the average contribution of the last two digits will be the average of 0, 0, 2, 2, 4, 4, 6, 6 and 8, 8. And what is this average? You can add them up, 0 plus 22 plus 44 plus 66 plus 88. That will be equal to 220 divided by 5. So the average will be 44 of the last two digits. As far as the first two digits are concerned, A, there is no real restriction that A has to be even. The only restriction is that A should not be equal to 0. So these can be either 1, 1 or 2, 2 or 3, 3 or 4, 4 or 5, 5 or 6, 6 or 7, 7 or 8, 8 or 9, 9. Again, by symmetry, the number of 1, 1s will be exactly the same as the number of 2, 2s, which will again be exactly the same as 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8 and 9, 9. So if you are trying to find out the first two digits of the average, it will be the average of all of these numbers. And what is the average of all of these numbers? You can sum them up. You will find out that the average will be equal to 11 plus 99, so that is 110, plus 22 plus 88, so again that is 110, plus 33 plus 77, so again 110, plus 44 plus 66, so again 110, and you have 55 in the middle. And 55 divided by how many such numbers are there? There are 9 such numbers. If you sum them up, this is equal to 440 plus 55, that is 495 divided by 9, that is equal to 55. So the average of all such numbers will be equal to 5544. So the correct answer will be option D. In this question, we are told that A, B and C are all positive integers such that the product of A and B is 432, the product of B and C is 96 and the value of C is less than 9.
and we are asked to find out the smallest possible value of a plus b plus c. If you look at the two equations that are given to us, we are given the product of a and b, and we are given the product of b and c. So let us divide one equation by the other. Therefore, what is the value of AB divided by BC? This will equal 432 divided by 96. You can cancel 24 from both the numerator and denominator. So this will equal 18 divided by 4, or this is equal to 9 by 2. We can cancel B from the numerator and denominator, or the value of A divided by C is equal to 9 by 2. This would imply that C is definitely an even number, because the ratio of A by C is 9 by 2 and A is a natural number. It would imply that C is an even number. So the value of C can be either 2 or 4 or 6 or 8, because we are told that C is less than 9. Now we know that A by C is equal to 9 by 2. So the value of A will be either 9 or 4 into 9 by 2. So this is equal to 18 or 27 or 36. Similarly, the value of B will be equal to 96 divided by C. So that would imply the value of B is equal to either 48 or 24, or 96 divided by 6 is 16, or 96 divided by 8 is 12. So these are the four cases that we'll have to consider. Now we'll calculate the value of A plus B plus C in each of these four cases, and then find out which of them is the minimum. So if you're trying to calculate the value of A plus B plus C, in the first case it is 2 plus 9 plus 48, so that is equal to 59. In the second case it is equal to 24 plus 18 is 42 plus 4 is 46. In the third case it is 27 plus 16 is 43 plus 6 is 49. And in the last case it is 36 plus 8 plus 12, so that is equal to 56. So the smallest possible value is equal to 46. In this question we are told that m and n are natural numbers such that n is even, and we are given some inequalities. We are told that all the three expressions m by 20, n by m and n by 11 are greater than 0.2 and less than 0.5, and we are required to calculate the value of m minus 2n. So let us analyze each of the three inequalities and try to figure out the values of m and n. The first inequality says that m by 20 is less than 0.5, which is less than 0.2. So let us multiply the entire equation by 20. So m is greater than 0.2 into 20, that is equal to 4, and it is less than 20 into 0.5, that is equal to 10. So what are the possible values that m can take? Because we know that m is a natural number, m can be either 5 or 6 or 7 or 8 or 9. Let us look at the second inequality. We are told that n by 11 is also greater than 0.2 and it is less than 0.5. So let us multiply the entire expression or the entire inequality by 11. So 11 into 0.2 is 2.2. This is less than n, which is less than 11 into 0.5, that is equal to 5.5. Now n is a natural number and n is also even. So if you are considering only natural numbers, the natural numbers between 2.2 and 5.5 will be 3, 4 and 5. But of this, because n is even, the only possibility is that n will have to equal 4. So let us look at the third inequality. We are told that n by m, this is greater than 0.2, which is again greater than 0.5. Now we know the value of n, it will equal 4. So 4 by m is greater than 0.2 and 4 by m is less than 0.5. If you are looking at the left hand side of it, this would imply that m is greater than 4 divided by 0.5, or m is greater than 8. If you are looking at the second inequality, 4 by m is greater than 0.2, or m is less than 4 divided by 0.2, or m is less than 20. So the values of m have to lie to the right of 8 and to the left of 20, but we also know that m will lie between these 5 values, that is 5, 6, 7, 8 or 9. So because m is greater than 8, the only possibility is that m has to equal 9. So m is equal to 9 and n is equal to 4. Therefore the value of m minus 2n will equal 9 minus 8, which is equal to 1. In this question we are asked to find out how many integers in the set 100, 101 ... till 999 have at least one digit that is repeated. So what is the total number of integers that are in the given set? They are the list of all 3-digit integers from 999 to 100. So the total number of digits, total number of integers in the given list is equal to 900, of which we are required to figure out how many integers have at least one digit that is repeated. Let us first calculate the number of integers in the given set which have no repetition. So if we find out the number of integers with no repetition, and let us assume that this is equal to n, then the number of integers which have at least one repetition will be equal to 900 minus n, which will be the answer. So let us try to calculate the value of n. So we have 3 digits that we need to fill up, and there should be no repetition between these 3 digits. The first digit can be any number from 1 to 9. The first digit cannot be 0, but it can be any number from 1 to 9, so it can be selected in 9 ways. Once you select a number, let us assume that you have selected 5. The second digit can be any number which is not equal to 5. It can be either 0 or 1 or 2 or 3 or dot 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 till 9. It just cannot be equal to 5. So again you can select this in 9 ways. Let us assume that the second digit you have selected is equal to 2, just for the sake of this explanation. Now the number of ways in which you can select the third digit will be equal to 8. It can be any number which is not equal to 5 or 2. So the total number of 3-digit integers that can be formed with no repetition is equal to 9 into 9 into 8, which is equal to 81 into 8, which is equal to 648. This is the value of n. So how many integers are there which have at least one digit that is repeated? It will equal 900 minus 648. This will equal 252. That is the answer.
We at Krakow provide all the previous year CAT papers along with many other MBA examinations such as IIFT, ZAT, SNAP, MAT, CMAT, TIS and PGDBA in the actual exam format. You can attempt them as a test and get a detailed analysis of your performance or download them as PDFs.
In this question we are told that n, x and y are positive integers such that n is equal to x plus y and 2 is less than x is less than 10 and 14 is less than y is less than 23. We are also told that n is greater than 25 and we are asked to find out the distinct values that are possible for n. So what is the maximum possible value of n? Because n is equal to x plus y. From the equation n is equal to x plus y, let us try to find out the maximum value of x. That will be 9 and the maximum value of y, that will be 22. So the maximum value of n will be 31. And what is the minimum possible value of n? Just from the equation n is equal to x plus y, the minimum value of x is 3 and the minimum value of y is 15. So the minimum value of x plus y will be equal to 18. But we are also told that n is greater than 25. So if n is greater than 25, what are the different possible values of n in this given interval? The different possible values will be 26, 27, 28, 29, 30 and 31. So the total number of distinct values that n can take is equal to 6. In this question we are asked to find out how many of the integers from 1 to 120 are divisible by none of 2, 5 and 7. Amongst the given list, what is the total number of integers? The total number of integers is clearly 120. It contains all the natural numbers which are less than 120. Out of this, how many are divisible by 2? The number of integers who are divisible by 2 amongst the given 120 will be equal to 60. They are all the even numbers, that is 2, 4, 6 dot 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 till 120. So the number will be equal to 120 divided by 2. How many of these are divisible by 5? The number of integers which are divisible by 5 is 120 divided by 5, which is equal to 24. And the number of integers amongst the given list which is divisible by 7 is the integral part of 120 divided by 7, which is equal to 17. Now amongst these, how many are divisible by both 2 and 5? That is, how many of these are divisible by 10? That will be equal to 12. This is 120 divided by 10, which is equal to 12. How many of them are divisible by both 2 and 7? This is 120 divided by 14 and we'll take the integral part out of it. So that will equal 8. And how many of these are divisible by both 5 and 7? That is, how many of these are divisible by 35? That will be 3. There will be 35, 70 and 105.
And how many of these are divisible by all of 2, 5 and 7? That is, how many of these are divisible by 70? You will have only one number, 70, which is a multiple of 70, which is less than 120. Now, if you are trying to find out how many of these numbers are divisible by at least one of 2 or 5 or 7, that number will be equal to 60 plus 24 plus 17 minus 12 plus 8 plus 3 plus 1. So, essentially that will be equal to 60 plus 24 plus 17 minus 12 plus 8 plus 3 plus 1. 60 plus 24 plus 17 is equal to 60 plus 41, which is equal to 101, minus 23 plus 1. This is equal to 79. So, 79 out of these 120 numbers are divisible by at least one of 2 or 5 or 7. So, the number of integers amongst the given list which are divisible by none of 2 or 5 or 7 is equal to 120 minus 79, which is equal to 41. In this question, we are asked to find out the number of pairs of integers a and b such that a is less than or equal to b and a into b is equal to 4 to the power 2017. 4 to the power 2017 is equal to 2 to the power 4034. Now, we have two integers a and b such that their product is equal to 2 to the power 4034. Therefore, both a and b should be powers of 2. So, let us assume that a is equal to 2 to the power x and b is equal to 2 to the power y. So, this equals 2 to the power 4034, or essentially x plus y, because 2 into 2 to the power x into 2 to the power y is equal to 2 to the power x plus y. So, x plus y is equal to 4034. We are required to find out the number of solutions for this such that x is less than or equal to y. We know that x is the only solution where x is actually equal to y will be if x is equal to y is equal to 2017. This is one solution. And what is the total number of solutions for x plus y is equal to 4034, where we are disregarding the condition that x has to be less than or equal to y. That is, if x is equal to either 0, then y is equal to 4034. If x is equal to 1, y will be equal to 4033 and so on. So, the total number of solutions for this is equal to 4035. Out of 4035, you have one case, as we have discussed earlier, where x is equal to y. This is one case. In the remaining 4034 cases, you will have by symmetry 2017 cases where x is less than y and 2017 cases where x is greater than y. So, if you are looking for the solutions where x is less than or equal to y, the total number of cases will be 2017 plus 1, which is equal to 2018. That will be the answer. In this question, we are asked to find out how many 4-digit numbers are there which are greater than 1000, such that all the 4 digits are distinct and they have 1 7 and 1 3, such that 7 comes before 3. So, let us consider two cases. We have a 4-digit number. Now, the first case is that the first digit is 7 and 3 comes somewhere in the remaining 3 digits, and the second case is that the first digit is not 7, and because 3 cannot come before 7, the first digit cannot even be 7 or 3, it is some other number, and 7 and 3 will come in this 3 remaining digits. So, let us look at the first case. This is case 1. If 7 is the first digit, we have to select a place for 3. It can be any of the remaining 3 places. So, we can choose the place for 3 in exactly 3 ways. And once we choose the place for 3, suppose we have chosen this to be the third digit, then we can choose the second digit and the fourth digit in exactly, because it can't be 7 or 3, it can be 8 into 7. The remaining 2 digits can be selected in 8 into 7, that is 56 ways. So, the total number of ways is 3 into 8 into 7, which is equal to 168 ways. This is the first case in which 7 is the first digit. Now, if you are considering the second case where 7 is not the first digit cannot be 7, it cannot be 3, and it cannot even be 0, because it is a 4-digit number which is greater than 1000. So, the first digit can be selected in exactly 7 ways. It can be any of the remaining 7 digits. We can select the places for 7 and 3 in exactly 3C 2 ways. That is, out of these 3 blanks, we can select 2 blanks in 3C 2 ways,
And once we have selected both the blanks, the place for 7 and 3 is already prefixed because 7 has to come before 3. For example, if you have chosen the two blanks to be the second digit and the third digit, then the second digit has to be 7 and the third digit has to be 3. That is, once we have selected the two blanks, there is no ordering again in place because 7 has to come ahead of 3. So once we have selected the positions for 7 and 3, we have also selected the first digit. So the only remaining digit can be selected in exactly another 7 ways, because it cannot be 7, it cannot be 3, and it cannot even be the first digit. So the remaining 7 digits can be allowed to take the last place. So the total number of ways in which this can be done is 7 into 3 into 7. This is equal to 49 into 3, which is 147. Therefore, the total number of 4-digit numbers which satisfy this condition is 168 plus 147, which is equal to 315. In this question, we are given a fraction n square plus 7n plus 12 by n square minus n minus 12, and we are required to find out the largest positive integer n for which the given fraction is also a positive integer. So let us assume that the given fraction is f, and this equals n square plus 7n plus 12 by n square minus n minus 12. Now we can factorize the numerator as n plus 3 into n plus 4 and the denominator as n plus 3 into n minus 4. So we can cancel n plus 3 from both the numerator and denominator. So the given fraction will just become n plus 4 by n minus 4. Now we are required to find out the largest integer n such that this is a positive integer. Now we can simplify f further so that it becomes n plus 4 by n minus 4, which is equal to 1 plus 8 by n minus 4. How did we come to this conclusion? It is because n plus 4 is actually equal to n minus 4 plus 8. So if you divide n plus 4 by n minus 4, this actually becomes 1 plus 8 by n minus 4. Now we are required to find out the largest positive integer such that 8 by n minus 4 is also a positive integer. Now we can easily see that this will happen only when n minus 4 is equal to 8 or n is equal to 12. Because if n is greater than 12, n minus 4 will be greater than 8 and this will not be a positive integer. Therefore, f, which is equal to 1 plus 8 by n minus 4, will also not be a positive integer. So the maximum value of n for which 8 by n minus 4 is a positive integer will be if n minus 4 is equal to 8 and n is equal to 12, in which case the value of the fraction f becomes 2. Because 8 by n minus 4 will become 1 and you have to add 1, so f becomes 2. So the maximum value, largest positive integer n for which this is a positive integer is 12. That is the answer. In this question, we are required to find out the number of pairs of positive integers which satisfy the equation m square plus 105 is equal to n square. So m square plus 105 is equal to n square. This would imply that n square minus m square is equal to 105, or n minus m into n plus m is equal to 105. Now here you should understand that because n and m are positive integers, n minus m is also a positive integer and n plus m is also a positive integer. Now in that case, we'll just do the factorization of 105 and then try to see which of the following pairs match up. So for example, all the factors of 105 are 1, 3, 5, 7, 15, 21, 35 and 105. These are the factors of 105. Now we want n minus m and n plus m to be complementary. Complementary as in their product should match up to 105. That is 1 and 105, when you multiply them, you are going to get 105. 3 and 35 will also get you 105. 5 and 21 will also get you 105, and 7 and 15 will get you 105. And n plus m will be greater than n minus m because n and m are positive integers. So what we can do from this is that the only cases which are possible are n plus m is equal to 105 and n minus m is equal to 1. The second case that is possible is n plus m is equal to 35 and n minus m is equal to 3. Notice that when you multiply them, you are going to get 105. The third case is that n plus m is equal to 21 and n minus m is equal to 5. And finally, n plus m is equal to 15 and n minus m is equal to 7. Now, if you calculate the actual values of n and m using these four equations, you will get that n is equal to 53 and m is equal to 52 in the first case. Similarly, in the second case, n is equal to 19 and m is equal to 16. The third case, n is equal to 13 and m is equal to 8. In the final case, n is equal to 11 and m is equal to 4. So these are the four solutions for the equation m square plus 105 is equal to n square. So the required answer is 4. All we have done is find the factors of 105 and then find the complementary factors of 105. Complementary pairs of factors. By complementary pairs, we are finding out the pairs of factors which when multiplied give you 105. Once you get them, you found out that there are four such pairs. The pairs are 105 and 1, 35 and 3, 21 and 5 and 15 and 7. For each one of them, you will be able to find a value of n and a value of m such that n square is equal to m square plus 105. So in this case, the correct answer is 4.
Google search Krakow free CAT mock. Click on the first link. You can attempt a free mock test which was attempted by 30,000 CAT aspirants in the actual exam format. After completing the test, you get detailed solutions, analysis and percentile along with your scorecard to gauge your All India performance. Click on the solution to get video solutions from our expert faculty.
In this question, we are given a product of three terms, 2 to the power 4, 3 to the power 5 and 10 to the power 4. We are required to find out how many factors of this number are perfect squares. So whenever you want to find out how many of the factors are perfect squares, you have to first do the prime factorization. In this case, 2 is a prime factor and 3 is a prime factor, but 10 is not a prime number. 10 is actually equal to 2 into 5. So the first step should be to actually do the proper prime factorization of the given number. So suppose the given number n is equal to 2 to the power 4 into 3 to the power 5 into 10 to the power 4. We can simplify this as 2 to the power 4 into 3 to the power 5 into 2 to the power 4 into 5 to the power 4. That is because 10 to the power 4 is equal to 2 to the power 4 into 5 to the power 4. This can be simplified as 2 to the power 4 plus 4, that is equal to 2 to the power 8 into 3 to the power 5 into 5 to the power 4. Now for this number, we are required to find out how many of the factors are perfect squares. Let us assume that a prime factor of this number is 2 to the power a into 3 to the power b into 5 to the power c. Now if this is a perfect square, then a has to be, all a, b and c have to be even numbers. So a has to be either 0 or 2 or 4 or 6 or 8. Similarly, b also has to be even, so b can be either 0 or 2 or 4. Similarly, c also has to be even, so it can be either 0 or 2 or 4. So a can take 5 values, b can take 3 values and c can take 3 values. So the total possibilities, the total number of factors which are perfect squares will be 5 into 3 into 3. This is equal to 45. But we are required to find out how many of them are greater than 1. One of the factors which is included in this 45 is 1. That will happen in the case where a is equal to 0, b is equal to 0 and c is equal to 0. So we have to remove that one particular case from 45. So the required answer will be 45 minus 1, which is equal to 44. Remember that to find out anything about factors, first do the prime factorization. Once you have the prime factorization, for a factor to be a perfect square, all the exponents of the prime numbers should be even numbers. Then you can easily calculate the required number, which in this case is 44. In this question, it is given that there is a 6-digit number in which the 6th digit is the sum of the first 3 digits. So let us put in 6 blanks first. Let the first 3 digits be a, b and c. So the 6th digit will be a plus b plus c. The 5th digit is the sum of the first 2 digits. So the 5th digit will be a plus b and the 3rd digit is equal to the first digit. So we are told that c is actually equal to a. So if c is actually equal to a
a plus b plus c will equal 2a plus b. And the second digit is twice the first digit. So we are told that b is actually equal to 2a. So again let us write the 6 digits with the new information. The first digit is a, the second digit is twice the first digit, the third digit is equal to the first digit, and the sixth digit is the sum of the first 3 digits. So it will be a plus 2a plus a, that is 4a. And the fifth digit is equal to the sum of the first 2 digits. So this will be equal to 3a, a plus 2a. And the fourth digit is the sum of the fifth and sixth digits. So the fourth digit will be equal to 7a. It will be equal to 3a plus 4a. Then the largest possible value of the fourth digit is. So notice that when we assume that a is a natural number, so all these, the 6 blanks are all single digit numbers. They can't be greater than 9. So when you are told that 7a is also a single digit number, that is 7a is less than 9, it would imply that a is equal to 1. We know that a is a natural number which is greater than or equal to 1, and we also know that all of these 6 digits are less than 9. All of them are single digit numbers. So the only way this is possible is if a is equal to 1. Then the number will be, the 6 digit number that we were discussing will be 1, 2, 1, 7, 3 and 4. And the maximum value of the fourth digit will be 7. This is actually equal to the only possible value of the fourth digit. This is equal to 7. In this question we are given that the product of two positive numbers is 616 and the ratio of the difference of their cubes to the cube of their difference is 157:3. We are required to find out the sum of the two numbers. So let us assume that the two positive numbers are a and b. We are given that a into b is equal to 616. We are also told that the ratio of the difference of their cubes, which is a cube minus b cube, we are assuming that a is greater than or equal to b. A cube minus b cube by a minus b whole cube is equal to 157/3. We are required to find out the sum of the two numbers. So we are required to find out a plus b. Note that there are two positive integers. So let us try to simplify the second equation. We know that a cube minus b cube is equal to a minus b into a square plus ab plus b square. So we can simplify this. A is clearly not equal to b because otherwise the denominator is not defined. So if you simplify the second equation, this will be a square plus ab plus b square by a minus b whole square is equal to 157/3. Now let us assume that a square plus b square is equal to k. Why are we assuming this? It will just simplify the simplification. It will make it easier. Second, we will try to find the value of k, because once we know the value of k, we know the product of ab. So if we add k plus 2 into ab, we are going to get a plus b whole square, and then we can try to find the value of a plus b. That is our strategy. So a square plus ab plus b square, this will be simplified to k plus ab is 616 by a minus b whole square is k minus 2 into 616, because this is 2ab. This is equal to 157/3. So using this equation, we will try to find out the value of k, then find out k plus 2ab, which will be a plus b whole square, then take its square root to find out the value of a plus b. Now you can simplify the given equation. So this will be 3 into k plus 616 into 3 is equal to 157k minus 157 into 2 is 314 into 616. If you simplify this, you are going to get 154k is equal to 616 into 314 plus 3 is 317. Now you can note that 154 into 4 is 616. So k is actually equal to 317 into 4. 317 into 4 is 1268. Now we are required to find out the value of k plus 2ab. What exactly is k? K is a square plus b square. So once we add 2ab to this, we are going to get a plus b whole square. So this is equal to a square plus b square. Now so a square plus b square plus 2ab. 2ab will be 2 into 616, which is equal to 1232. So this will be 1268
plus 1232. This will be 2500. This is a plus b whole square. So you can find out that the value of a plus b is square root of this, which is equal to 50. This is the answer that you are required to find out. There are many ways to solve this. Using these two equations, you can actually find the value of a and b, or there are multiple ways in which you can factorize it. But once you know that you need to find out a plus b, you have to look at what is the easiest way in which I will get there. And over here, if you are looking at both the equations, you can figure out that you can calculate the value of a square plus b square very fast. And so you can calculate the value of a plus b whole square in a quick manner. This will just solve some time. In this question, it is given that Ashok was multiplying three numbers, and instead of 37, he took 73 as one of the numbers. So suppose the three numbers were A, B, C, and C is 37. Instead of 37, he took 73, because of which the product went up by 720. So the product went up by 720. We are required to find out the minimum possible value of the sum of the squares of the other two numbers. So basically what is given is that 73 into AB, which is the new product, is greater than 37 into AB, which is the original product, by 720. This is what has been given. Now if you simplify this, 73AB minus 37AB will be 36AB is equal to 720, or the product of A and B is equal to 20. We have been given this. Now we are required to find out the minimum possible value of the sum of the squares of the other two numbers. So we are required to find out the minimum value of a square plus b square. Now what we do know is that a square plus b square is greater than or equal to 2ab. This is simple application of arithmetic mean greater than geometric mean, and the equality will occur when a is equal to b. If a is equal to b, only then a square plus b square will equal 2ab, which actually equals 2a square. So in this case, we know that the minimum value of a square plus b square, which is the sum of the squares, is equal to 2 into ab. The value of ab is 20, which is equal to 40. So if the other two numbers were equal and they were actually equal to square root of 20 each, that is when the minimum value of a square plus b square occurs, and it will equal 40. So the answer in this case is 40. In this question, we are required to find out the number of integers x such that 0.25 is less than or equal to 2 to the power x, and 2 to the power x is less than or equal to 200, and 2 to the power x plus 2 is divisible by either 3 or 4. So let us first figure out what are the values that x can lie between, that is the range of x. Then we will figure out if 2 to the power x plus 2 is either divisible by 3 or 4. First we know that 0.25 is less than or equal to 2 to the power x. 0.25 is 1 by 4. This is equal to 2 to the power minus 2 is less than or equal to 2 to the power x. So this would imply that x is greater than or equal to minus 2. Similarly, we know that 2 to the power x is less than or equal to 200. So 2 to the power x, if you are looking at the powers of 2, the powers of 2, the highest power of 2 which is less than 200 is 128, and the next power of 2, that is 256, is greater than 200. And 2 to the power 8 is 128 is 2 to the power 7. So x is less than or equal to 7. So 7 is greater than or equal to x. So the values of x, the integral values of x have to lie between minus 2 to 7. Now amongst these values, we are required to find out what are the values for which 2 to the power x plus 2 is perfectly divisible by either 3 or 4. So let us write it down, because there are only 7 plus 0 is 1, 8, and minus 2, that is 2 more, that is a total of 10 values are there. We will write them down and try to see which of these values is perfectly divisible by 3 or 4. When x is equal to minus 2 or minus 1, 2 to the power x is a fraction. 2 to the power x is either 1 by 4 or 1 by 2. So the question of it being perfectly divisible by 3 doesn't arise. So for x is equal to minus 2 or minus 1, 2 to the power x plus 2 is not divisible
by 3 and 4, 3 or 4. When x is equal to 0, 2 to the power x will be 1. So 2 to the power x plus 2 will be 3. So this is perfectly divisible by 3. We need to check whether it is divisible by 3 or whether it is divisible by 4. Any of the two will work fine. When x is equal to 1, 2 to the power x is 2, plus 2 will be 4. This is divisible by 4. Similarly, when x is equal to 2, 2 to the power x is 4, plus 2 is equal to 6. This is divisible by 3. Similarly, when x is equal to 3, 2 to the power x plus 2 will equal 10. This is neither divisible by 3 nor is it divisible by 4. When x is equal to 4, 2 to the power x plus 2 is equal to 18. This is divisible by 3. When x is equal to 5, 2 to the power x plus 2 is 2 to the power 5 is 32 plus 2 is 34. This is also neither divisible by 3 or 4. When x is equal to 6, 2 to the power x is 64 plus 2 is 66. This is divisible by 3. And finally, when x is equal to 7, 2 to the power x plus 2 is 2 to the power x will be 128 plus 2 is 130. This is neither divisible by 3 nor is it divisible by 4. So the total number of integers that are divisible by 3 or 4 is 1, 2, 3, 4 and 5. So in this case, we have first found out the range of x, that is what are the values of x, what are the values, integral values that x can take. Then we have enumerated each one of them and tried to see if the numbers are divisible by either 3 or 4. In this case, we have found out that for 5 integral values of x, all the conditions are satisfied. In this question, it is given that the sum of the squares of two numbers is 97. So let the numbers be a and b. So a square plus b square is given as 97. Then which of the following cannot be their product? So we are looking for possible values of ab. One of the first thing that you should remember is that if both a and b are positive, then we can use arithmetic mean greater than geometric mean. Even otherwise, because a plus b whole square is greater than or equal to 0 and a minus b whole square is also greater than or equal to 0, for any two numbers a and b, we can easily get a range for ab. So for example, if we are expanding this, it will mean that a square plus b square minus 2ab is always greater than or equal to 0, or a square plus b square by 2 is always greater than or equal to ab. Similarly, expanding this, you get that a square plus b square plus 2ab is greater than or equal to 0, or a square plus b square by 2 is greater than or equal to minus ab. Now because you want to find out the values for ab, you multiply both sides of the inequality with minus 1, and as minus 1 is less than 0, the sign of the inequality will change. So minus of a square plus b square by 2 is less than or equal to ab. So here you have a lower bound and an upper bound for ab. It will vary from minus of a square plus b square by 2, it is definitely greater than this, and the maximum possible value is a square plus b square by 2. In this case, we know that a square plus b square is equal to 97. So ab will vary between minus 48.5, which is minus 97 by 2, and the maximum possible value is 48.5. So this is the interval in which AB will lie. If you look at minus 32, it will lie within the interval. So this is possible. So this can't be the option. We are looking for the option which is not fitting in this range. If you are looking at 16, even 16 lies within this interval. So even option B is incorrect. If you are looking at option C, it is 48. 48 also just about lies within the interval. So even this is not the correct option. If you are looking at the final option, that is 64, 64 is greater than 48.5. So it won't lie within this interval. So the correct answer is 64. The product of AB will not equal 64. In this question, we are required to find out the smallest integer for which 4 to the power n is greater than 17 to the power 19, and we are required to find out that smallest integer is closest to which of the following options. Now if you look at the options and if you look at the question, it looks slightly complicated. It would require a lot of understanding, because we don't know the value of either log 17 or log 4. If you had some understanding of these logs, then probably we could have solved it.
But the interesting part about this question is that you don't need to calculate the value of n. You can just look at the options and then figure out which of them is closest to n. Now if you look at 4 to the power n, you know that 4 to the power n is equal to 16 to the power n by 2. Now you know that 16 to the power n by 2, if it is greater than 17 to the power 19 as is given, because 16 is less than 17, it would definitely imply that n by 2 is greater than 19. Because 16 is the smaller number, if it is raised to a much higher number, only then will it be greater than 17 to the power 19. Or this would imply that n is greater than 38. So now if you look at the options you have are 33, 37, 35 and 39. You know that there is 38 here and all the other options are to the left of 38. There is only one option which is 39, which is greater than 38. So you know that of all the 4 options, the option which will be closest to n will be 39. So the answer in this case is 39. We know for sure that n is greater than 38, and so the only option which is closest to it is 39.
If a, b, c and d are integers such that a plus b plus c plus d is equal to 30, then find the minimum possible value of a minus b the whole square plus a minus c the whole square plus a minus d the whole square. Now, if you can see, these a, b, c, d are integers, so they are real numbers. So this is the sum of squares of 3 real numbers essentially. So this is real number 1 square plus real number 2 square plus real number 3 square. Now, and these will be actually integers, not just real numbers. Now, given this fact, each of these values will at least be greater than or equal to 0. The fact is that the min value that these can take is 0. And when will 0 occur? The 0 will occur when these values are as small as possible. Therefore, 0 or near about 0 will occur when a minus b, a minus c, a minus d is as close to 0 as possible. And that will basically occur when a, b, c, d are as close to each other as possible. So that means that a, b, c and d should be, the sum of these is 30 and these should be very close to or almost equal to each other. So what would be the case if these are all equal to each other? If these are all equal to each other, then this value is 0, this value is 0 and this value is 0. Therefore, the minimum possible value of that equation in that case would be 0. So if suppose these are equal to each other, that means a equal to b equal to c equal to d is 30 by 4, that is 7.5. But we know that these are integers, so this value cannot be 7.5. So we have to find the value of a, b, c, d such that they are close to 7.5 but they are integers. So one way we can distribute 30 into integers such that the sum is 30 and they are as close to 7.5 as possible is 8, 8, 7 and 7. Now you can distribute these in any way as such, but the way where you can minimize the value of a minus b, a minus c and a minus d is if a is 8 and one of b, c, d is 8 and the remaining are 7 and 7 as such. So in that case we get the value of the equation as 8 minus 8 the whole square plus 8 minus 7 the whole square plus 8 minus 7 the whole square. So this is 0, this is 1 square, this is 1 square, this is essentially 1 plus 1, so that is 2. Therefore, the minimum possible value of a minus b the whole square plus a minus c the whole square plus a minus d the whole square is 2. So the thing you have to remember is that the sum of squares, this value cannot ever be negative. The min value it can take is 0. And because these are integers, this value will also be an integer. So you have to find such a way that this square is a minimum possible integer. And the minimum possible integer, which is a perfect square, is either 0 or 1. Now you have to distribute 30 in such a way that the sum of squares is either 0 or 1. So we made one of them 0. We couldn't make more than one 0, so we had to make two of them 1s. So the sum of the equation, least possible value of equation, answer is 2. So this is how we solve questions when we have to minimize the equations. Always remember when the limiting condition is symmetric and you have to find the equation that is also given is somewhat symmetric in BCD. If you see this equation is symmetric in BCD, So given the fact that it is symmetric in BCD, at least BCD should be equal to each other. That is something that you should always remember when you have to find the minimum value of something and the limiting condition is symmetric and the given expression is symmetric in certain variables, then those variables should be equal to or near about equal to each other. In this case, there was an additional constraint that they had to be integers, so it could not be equal as such, but BCD should have been as close to each other as possible. Now it is like the sum of squares in addition to that. So all of them have to be very close to A also for you to minimize the overall value. So just using this concept, we could say that A, B, C, D should be either equal or as close to equal as possible. From that you could find out the remaining answer easily.
It is given that the product of three consecutive positive integers is 15,600 and we are required to find out the sum of the squares of these integers. Let us assume that the three integers are x minus 1, x and x plus 1. What is given to us is that x minus 1 into x plus 1 is equal to 15,600, and what we are required to find out is the sum of the squares of the three integers, that is x minus 1 whole square plus x square plus x plus 1 whole square. Now if we simplify the given expression, we would get that x square minus 1 into x is equal to 15,600, or x cube minus x is equal to 15,600. Now you can use trial and error to figure out the cube which is closest to 15,600. You can easily find out that 25 cube is equal to 15625 and 25 cube minus 25 will therefore equal 15,600. What we have done is figure out the cubes which are closest to 15,600. We have identified that 25 cube is very close. So 25 cube minus 25 is actually equal to 15,600. So the value of x will be 25. So to calculate the sum of the squares, we need to calculate 24 square plus 25 square plus 26 square. 24 square is 576, 25 square is 625 and 26 square is 676. So if you sum them up, there will be 7, 14 plus 7, 1. So this is 1877. That is the sum of the squares of these three integers.